you have to adapt because, like every other industry, they have different requirements, different strategies, and different validation processes. And the automotive industry has a process that takes you years until you start your serious production. And that's thing definitely will be different.
Hello, everybody. It's time for a new episode in our podcast, The Gold Casters, how to be profitable and make more money in the casting industry. And today we have a very special episode. It is a little bit on the format, the things you would like to ask somebody, but haven't found anyone to ask about telecom. Telecom industry is an important industry in casting. They are having different requirements, and they are very often the first suggestion that is brought up to lift the company in terms of turnover and profit margins and so forth. But we have seen many larger foundry organizations fail, despite that we all know that these are very good in know-how, technology level, size, global reach, whatever. So this episode has the ambition to take you from A to Z in telecom, and in the end, we will discuss what you need to do to become a telecom supplier of die castings. So let's go.
Perfect. Thank you for that introduction into the topic. And today, my role will be more like asking you the questions, as you've been working in the telecom industry for quite a long time in your past. So yes. Let's start with the general overview. What's the size of the industry?
300 DC machines fully employed. That might be a little bit too quick, but let me put it this way. There are the five big ones, which are Samsung, Ericsson, Nokia, ZTE, Huawei. And if I make a very rough calculation, I would say that these companies are representing some 150, 200 die casting machines, predominantly larger machines, 2,700 tons up to 5,000 tons, for example. Then you have another 150 machines that comes from side equipments and also bought final products like radio filters, for example. In the past, radio filters were actually managed by the big fives directly, but now it has been a commodity. So how did this happen? Let's start with the history lesson.
Let me just put in one question more regarding these 300 machines. Do these top 5 countries have their own foundries, or is it all sourced from the market?
It's all sourced from the market. And it comes from history. So let me give you an overview of the history of telecom as we know it. Because when we say telecom, we mean cell phone systems. Okay, radio systems, basically. There's a lot of other telecom, but younger people younger than 40 years old, they don't understand that we actually had phones with wires and we kept them like this and, dialing numbers and that stuff. But I started in the telecom industry 1997. And in my interview, which took place in July when everybody was on vacation, 2 gentlemen seriously told me that, Staffan, we have invented GSM here. And if we are lucky, we're going to sell it outside Sweden. So that was the start of it in 97. And then it was the 1G. Now we talk about 5G. We'll come to that later. Interesting enough was that in Sweden is a place with a long distance between people. And one of the ideas from the beginning was that maybe it's easier to send a radio signal than actually have a copper wire. That was one of the thoughts they had. So they developed something called NMT, which was an analog radio, a normal radio, if you like, a radio that firefighters or hunters are using. But then they realized if we digitalize this, we can actually increase the bandwidth, send more data per second. So this was launched. I started work at Ericsson, and we had the sales were pretty good, and it just exploded. We grew 10% proportional every month.
That's great.
That doesn't make it. Yeah, that doesn't make much of a change, between month 1 and 2. But add 12 months, so it was skyrocketing.
Double the size.
Yeah. Oh yeah. And the interesting thing was that why did this happen? Well, first of all, it was a massive rollout in UK and Germany and Sweden, of course, that started this. And this massive rollout showed one thing that's typical for telecom. The system comes first, the applications comes later. So first people rolled out these systems. They didn't make too much money on them. Then they invented prepaid. That made it so easy. You bought a cell phone, a SIM card, you loaded that with a amount of data, you paid some euros or whatever, and then the market exploded. People talked like crazy. Then came 2.5G, we call it GPRS back in the days, and it was a hilarious high bandwidth. You could actually also send text messages. It was super hot 1999.
I can remember I had 10 free SMS per month.
Yeah.
And my phone only could save like 10 messages. And you had to think, okay, which of them can I delete now because I want to get the 11th message?
Yeah, exactly.
Good times.
Then a little bit later, the innovation of 3G was more driven by, and also 4G in some extent, the start of the video. And for you kids, if we have any kids listening to two old guys talking in a pod about die casting and casting, you don't realize. But back in the days, we didn't have YouTube. There was no YouTube. So when YouTube was invented, a great panic was that, we need a cell phone system that can cope with that amount of data. Very Swedish here. So then it evolved to something, I would say 4G more or less, that anywhere, anyhow, you want to see the instruction manual of your lawn mower, or how to create a beautiful garden, or who is selling that lipstick, or whatever. And of course, it follows that information explosion. Then you might
remember,
ask,
as it first started, there was one button. If you pressed it for long, it would connect to the internet, and it was crazy expensive.
It was.
So if you press it in your pocket without realizing it, all your budget on the prepaid card was drained. Yes.
And I find it another difference between me and my kids, that when I thought I was young, around my 30s, and you went into Wayne's coffee shop or Starbucks, in the beginning, you actually had to pay for using the Wi-Fi. Do you remember that?
No.
You actually bought a coupon, and then you can log in, and then you had a coupon for €5 worth of data, and that was sucked up in 3 minutes or something, and then you had to buy another coupon.
So like with the airlines today, where you can get internet access while you're on the plane, but you have to pay.
I actually sold my flat on the airplane above Iceland once in the middle of the night on a flight from Dearborn. Anyway, now, so why do we need 5G? Here comes the thing. 5G is real-time radio. It is without any time delays in the signal system. And that means that it opens up for completely new applications, meaning self-driving cars, basically. Because a self-driving car it's very neat if it's communicating in real time if something happens, and the cars themselves are radio base stations and all that crap. Anyway, so we're talking about 5G now. The 5G market is what everybody is looking at, or maybe not everybody, but again, if you talk to someone, it's very often they say, we might look into something else than automotive. We're thinking about telecom. And I have this conversation pretty often. And the interesting thing is that, I don't know why, but bigger automotive suppliers think that this is just for grabs. So here comes the first question. Is the telecom industry for grabs? Is it easy to become a supplier to the telecom industry? What do you think, Fabian?
You have to adapt because, like every other industry, they have different requirements, different strategies, and different validation processes. And the automotive industry has a process that takes you years until you start your serious production. And that's definitely will be different.
It is. It is. I would like to put it like this. Let me put the negative things first. Number one, telecom parts are damn difficult to cast. Because
can I stop you right there? Why are they different and very difficult to cast? What does a typical telecom part look like?
It's a heatsink. A heatsink, a radio filter, and then there's a bunch of small castings. But let's take the heatsink, because everybody's seen the heatsink. You have those fins, you know. And here comes the problem. Why did I discuss all these generations? Well, in generation 1, 2, and 3, heat conductivity was not super critical. And why is that? Because they had a lower frequency. The higher the frequency, the bigger the losses. And every new generation has a higher frequency band that they're operating on. And 5G is up there. When you double the frequency, you diminish the radius around the radio base station where it can reach for the same energy with half. So what do? You pump in more energy for the transmitting of the signal. And more energy is basically 90% losses from the electronics that has to be taken out of the radio base station. So there goes your explanation. First explanation on the castings for 5G, why they are difficult. Because number one, you have to cast with a high thermal conductive alloy.
And if you look at the high pressure die casting market, the standard alloy is something like ALSC10, ALSC11.
Yeah.
With the high silicon content, there's not too much of heat conductivity. So you have to reduce all the elements that are within our casting to get the heat conductivity up.
Yes.
So for high pressure die casting, you end up with something like 120 to best case 140 watts per meter Kelvin. Pure aluminium is around 220.
Yeah, and if you go down to 2.5-3% silicon, you're up to something 180, 190, maybe 195.
But without heat treatment, that's important, because it's not only which elements are in there. There's also important the grain size, because every grain boundary is a barrier for the heat conductivity. All the impurities, porosity, all that is a problem to deliver the heat.
So here comes the problem number one, alloy. You cannot use ADC 12, 226, 46,000. You cannot even use A356 because it's just up to 160, 165. So here's the problem number one. If you want to go into telecom to become a caster of heat sinks, which is the expensive thing, you have to be able to cast in something different.
So
problem number two.
For the foundry, you need a new alloy, a new melting furnace to be able to deliver the project.
Yes. Problem number two, in 1G, 2G, 3G, 4G, we have those linear, nice looking, typical heat sinks where the fins are in parallel like this. That is probably history now, because the new generation of heat sinks we see have angled fins. So they are like, the track of a tractor on a field like this, because what they do,
so they're in 45 degrees or 90 degrees to each other. Just that there is turbulence of the airflow, because laminar airflow builds up a barrier between the heat sink fin and the moving air, and there's no heat exchange. So you can deliver the heat from the electronics to the fins, but not into the air. If you have these angled fins, probably suddenly there is disturbance, there's turbulence, and the turbulence takes off the heat of the heat sink, and now the electronics can be cooled.
Yeah, and the best example of this, which is out there in the high volume production, is Elon Musk. You have to love the guy. He has a Starlink program, and all the radio base stations have this angled fin structure. So this is why we know it. But we know that others are making the same design. So that design is the nightmare of the casting engineer, because regardless of where you place your ingate, you will have a problem. So that's number 2. Number 3, a telecom casting consists of alloy, casting, machining, electroplating, and powder paint. A normal automotive casting is ingot, casting, quick machining, done. And that means that
heat treatment in between passivation layer, but then you're basically done.
Yeah, you're basically done. So if you're going this way, so either you have to invest like crazy, or you have to find sub-suppliers that can support you in everything from your offering and then later in your production. And to be honest, which is your problem number 4, the suppliers that are around, they have been doing this since 1996. They know their shit. They have supply lines. They know everything about the electroplating. They have understood how to make money out of the complete package. And this is a major, major problem, I would say, for if you want to enter this business at all. So these are the technical challenges that you will see. But here comes the bad news. That's not the important difference. The important difference is the culture difference between telecom and automotive.
Yeah,
it is a different planet.
Elaborate more on that, because we now need for our audience the interesting parts why we should go into telecom, because now it sounds quite negative and a direction not to go as an automotive foundry.
Yeah, I'm just trying to picture up that it's not that easy. It's not going to the supermarket and, hey, I want a box of chocolates. I buy a box of chocolates and then you're a done deal. You have to be aware that if you are going this direction, these are the points to be taken care of. But why you should be there is also in the difference of the culture, because it's much nicer working in telecom. First of all, you will have a higher profit margin. End of story. That's the fact. You will have a more costly part. You deliver something for 100 euros instead of 25. You have more value add into the part. You are more important for your customer. That's a simple fact. So that's good.
Great to hear, especially with the margins drop in the automotive industry. And you have someone, especially if you're going into these high conductivity alloys, where your competition is machining it, you're looking at it quite profitable.
Yeah, and the second thing is that a telecom customer, if what I know, I don't know them all, but I know pretty many of them, they are more loyal to you. They are coming from low volumes. They have a problem with forecasting. Forecasting system in telecom is useless. They develop 5 parts. They don't know actually which will be the high runner or not, but they have a way to support you. They want you to survive. So that's the good thing out of it. But the biggest difference in culture is that a telecom customer has the same interest as you, the deliveries. And this is so funny. In my workplace, we had a very, very high valued brand in the foundry industry. Their engineers were standing around the conference room. On the other end, we had engineers from a telecom OEM. And the guys from the telecom OEM started to tell these foundry men what kind of quality defects they allow. And they also showed a document where, it looks like a mice has been eating on the fin, for example. Yeah, in this area, that's perfectly okay, and these automotive born and raised people, they didn't understand. I think they were joking. But it comes to this. When telecom needs the parts, you're in the same boat. There's less shouting in telecom. It's not this customer seller thing. It's not this master and slave thing that you'll find in automotive. It is actually much nicer. If you find your way into telecom, it is probably a very, very interesting segment to work with for your foundry. And here comes another thing. Telecom, by historical reasons, has been 80% China. Since 1999 onwards, China has demanded a high level of local content. Impossible to have circuit boards and everything from China meant that you had to buy more castings and then ship them to Europe to get the value up to please the Chinese government. And that led to castings, sheet metal, and screws and bolts and all these things were more or less bought in China then exported all over the globe. This is changing by a number of facts. Number one is actually sustainability, that local sourcing is preferred. Number two, it is by law in the US and UK and some other places not allowed to mix suppliers any way you like them anymore. If you have a supplier,
US, Huawei is now forbidden to deliver the 5G industry.
I think in UK too, actually, in Sweden of all places, and this is open up for a great changeover in how they actually purchase things. So, if you look at the big five, you'll find that they are speaking about Asian non-Chinese, meaning that if you're in Vietnam or India or something, you are actually in the right spot. And also they are looking more and more in Eastern Europe. And I think in a near future, they'll probably start to look more in Mexico, North America as well. So this is opening up that you will find a room full of purchasers that wants you to become a supplier in an interesting region. So only your address could actually be an asset in this discussion.
Yeah, that's great. So if you're in a market that's growing in size, that buyers are desperate to find someone locally, sustainability is a big point, which you have to do anyway. So it's a great industry to start in, especially when it's growing and everything just starts small.
Yeah, but again, to be a little bit negative, it's growing from low numbers because, and this is so interesting that all the new generations had an SOP, start of production, that has been delayed. And one of the reasons is courts, that people are actually bringing the competition to court. They didn't get the bandwidth, they didn't get the frequency, and then they are held up in court, like typically US, for 1 or 2 years. And once it's resolved, then they really need the delivery. So if you look at the number of contracts they have for rollout of new generations, it's always a very big pile, and then comes 2, 3, 4 years where the volumes are super high. But telecom is always repeatedly in a crisis. I can take one example. Ericsson is a Swedish company. They have been hours away from bankrupt 5 times.
That sounds not too good to be the customer of a company that's on the verge of bankrupt constantly.
Yeah. The first time was when the Russian Revolution took place and all the factories were in St. Petersburg. The second time was 1976. They made a bad judgment of what kind of a switchboard system to start to deliver, and they were held back for 2-3 years, no sales in 2 years. And somewhere in the 80s, they have that same problem. I think it was 84. In the midst of the build-up of the GSM system, Ericsson went all in. They had a prototype budget of some 200 million euros or something. You can imagine the cost. And then the delay of the roll-up, it was a year that was very, very difficult for the CFO Ericsson and so forth. So telecom is always volatile like this. And it's not that easy that you can say that it follows the global economy. It doesn't. You can have a downturn.
The automotive industry follows the global economic. Yeah. If you have something that doesn't follow it, so it's basically a counterpart to your existing product portfolio.
Yeah, it lives its own life, I would say. So if you are a little bit lucky and you have 20-30% in telecom, it is actually probably the way to make to optimize your profitability. I would say that. But again, you have to do the homework, because the days where in the GSM time, then I was working for Ericsson, you were interested in everybody that brought you forward. Today, you have to be a little bit special. You have that right address. You have done your homework when it comes to supply lines and supply flows, different processes. You know something about alloys. Boom, boom, boom. You have done that homework. Then you are super interesting. But here comes another thing. I think after discussing with 3 of the big ones, they are quite disappointed or they're questioning automotive casters because of time.
What do you mean by that? It's like, is it the time frame, delivery time? What is the issue with times?
They're too slow. Because a normal time from the nomination, when you receive the letter of nomination in telecom, regardless of who of the 5 you're talking about, is between 5 to 6 months to first delivery.
That's quite short. It's usually automotive. You have a few years until SOP.
Yes.
And usually tool making time is about 2-3 months, depending on the complexity.
Yes. So what it means is that the day after you are nominated, you have your final meeting with your tool maker. You do the design freeze in week 2 together with your customer. Then you start to build a tool. As soon as you have the tool, you do the first auto tool. And after, I would say 4 months, you actually squeeze out 500 castings that goes into the production flow of the machining and the electroplating and the powder painting, blah, 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 up to be verified. And then you have a customer that have your same interest as you. So if you have said week 17, I'm delivering 50 parts, they will be standing there taking the 50 parts, do the verification and say, perfect, these 5 points you have to correct to the next time, but we use them. Basically, on the top level, this is how it works. But an automotive caster says, very often with the attitude, we know castings. And that's true. They know castings in automotive, where you can fiddle around and the last digit is super critical. Another example of this with time, if you you do your homework, everybody is interested, you're courting a little bit, and some nice guy from Finland, Sweden, Korea, whoever, sends you an RFQ. You don't have 6 weeks. You're supposed to deliver that very, very quickly. Even if they say like, yeah, you can take the summer because we're going on vacation. They kind of expect that you are fast. It's even better to send in something where you say, we don't have the exact number of the powder paint, but we think it's 19.58 euros. But let us come back in week 37 with that one. Because
so here's the big difference in the automotive industry. Yeah. If you put it in the system, it's locked in. These are the prices. And you say it's better to say, okay, if you don't know the price, estimate something, mark it as an estimate, and then there will be discussions later.
Yes, because it's better to actually be there, have something that is 95% correct. And I mean, Fabian, you're a German. I mean, it's not in. If you're a German foundry, you can imagine how you feel about that. So it is very, very quick. Another interesting thing in telecom is that they all try to combine article numbers. So if they have 2 that are cannibalizing each other, 2 different frequencies or whatever, they try to make you do both, so you can balance, so you actually have something to do in your machines. And that's another difference.
For you, it's just like, do I put up tool A or tool B?
Yeah, because now they need more tool A, for example, and then both are casting it.
But it's pretty nice, so that you have both products. If they cannibalize each other, your total volume stays the same.
Yeah, because the forecast is going like this. So you will have bad days as a foundry to the telecom industry. That's for sure. So given the movement on the geopolitical arena, giving the sustainability and for people making the homework, I would actually make a trial. But here comes another but. Why focus on the big five? Because Samsung, Ericsson, ZTE, or Huawei, or these guys, they're making the base station. They are probably asking you for your 3,500 ton machine for making the heatsink, etc., etc. It's very complex. But never forget the other 150 machines that are out there, because you need an antenna, you need a repeater, you need a zillion of small things in building a telecom system. So it's very popular. You're from Sweden. Do you know anybody at Ericsson? Yeah, a bunch. Do you know anybody in Nokia? Yeah, of course, because it's our neighbor. But never forget that there's a radio filter, there's a cover, there's a lining, there's a zillion of parts that are actually made outside that probably could be very, very nice to look at, because those micro OEMs, they are serving all five.
So you basically can get the big parts as a lighthouse project, and then while you're going, you also get smaller parts that fill your small machine capacity, which is quite tough now in the automotive industry to find parts anyway.
Yes.
So it's like a double win.
Yeah, you can actually do that. And
I think for these parts, you don't have the same heat conductivity requirements than for the heat sinks.
Yes and no. There are so many different applications. I mean, you have the fiber system, for example, that consumes, I don't know how many machines outside of those 300. I can imagine another 50. So you have some repeaters, you have different antennas. I mean, how many different antennas do you have? From the Omni 360 degrees to a very, very focused antenna or adaptive antenna or whatever you look at. But the higher frequency you get, the more intelligence you get into those systems. The more intelligence you have, the more of the equipment you want to have before the cable. This is another thing, because every cable is a loss.
The variation in parts goes down because the software variation of the circuit boards gets increased. Is that the right understanding?
Yes and no. The bandwidth creates a need for more article numbers on, let's say, a heatsink, for example. So instead, in the old days, you could be running a telecom company with 5 different models, and then you're home free. Today, they probably have 20 or 25 or maybe more. But it's also true that most of the development is basically software. So the first 5G bases that went out in the world were software adapted 4G equipment. So you put in another software changes on the circuit board, and boom, boom, you have 5G. So it is a little bit tangled, sometimes a little bit difficult. But again, if you're a foundry, you're in the right spot. And here comes the good news. If you're not an automotive foundry, it's actually a benefit.
Interesting, because let me guess, because you're not set in the ways. Okay, we have now SOP. It will take me 2, 3, 4 years until it starts, and have time to do everything. If you're the equipment manufacturing delivery for tier ones or whatever, or other industries, you're basically used to that.
Yes, and you're set up like that. You have your quality people are, looking for the minds and the do's and don't. All these things. In telecom, it is more. It's more simple. You can actually call a guy and have a discussion. Why is this drawing like this? Well, because of this. We can never change because that has to do with radio frequency. But the interconnect, yeah, sure. It's much, much, much easier. And another thing I would like to end up with is that in telecom, any kind of innovation is highly appreciated, but not as a rule discussed with your competition. I always had the sense in automotive that if you have a very nice thing going, they kind of want to have a second source directly, and then they search for someone who has exactly the same innovation as you have. And if you don't, they want to spread what you actually know. So you will be the first source, but you will have a second one. That happened us late in a few years ago. So you can be more innovative to bring interesting ideas. For example, precasted band pass filters. I mean, that's Greek for many people, but they kind of appreciate that you can precast things. And all of a sudden, maybe you can have a little bit of a more of a margin because you bring something to the table that don't necessarily has to be taken away from you from day one. So again, they want you to survive.
Yeah, that sounds really interesting. If you can do these innovations that change a bit of your process while you're still delivering. If you do it in automotive, you have to go with every tool, every change, with everything. You have to go through a validation process that has to be checked by every quality department they can find.
Yeah.
And then when it's approved, if it's not within some specification, then nice, thank you for your intelligence, but no, we don't accept it. Go back to the way you did it before, and you lose money on it.
There's a brilliant way to describe this by talking about alloys. In telecom, among the 3 out of the 5 big ones, as I know for a fact, they are interested in high thermal connectivity. You suggest something, and you follow the document when it comes to corrosion and other stuff, and then you're okay. It's not the world standard. That will never ever happen in
so the alloy itself is not specified. As long as you reach a certain heat conductivity and a certain corrosion resistance,
yes,
you're fine.
Yeah, some mechanical properties that are not that high. But could you imagine a day when a German car manufacturer asks you for an RFQ and you respond, yeah, dear customer, I solve it for this price and I will use aluminum silicon 4 Fe with some copper in it. And they will say, oh yeah, great idea, let's go.
No, that doesn't really happen.
No, maybe a Tesla, but otherwise, no. So I think that is the biggest evidence that I'm not bullshitting. I mean, take a look. Make a call. You probably know someone at Nokia, Ericsson, Samsung, or the rest of the guys, and say, if I would propose this, would this be interesting for you? And they will probably say yes. Standards in alloys, follow the track, fulfill the requirements, then you're okay. I would say this is the big difference, the way they regard your innovation. If you solve a problem with angled fins, they're happy. They have a problem because they need a second source. So they probably ask you politely, could you please cooperate with this guy because he is in North America and you're in Eastern Europe and we need the sourcing in 2 places. Yeah, okay. Then it's a business discussion. Or to put it like this, you're regarded as a grown-up in telecom. You have a valid point, a higher degree than in automotive.
That's interesting. So as a requirement for the foundry, you need a different culture, how you work with your customers in telecom.
Yes.
So people need to be more quick, more open-minded, discuss the things directly before having endless meeting internally until someone is able to do a decision.
Yeah, because the ship would have sailed directly. But again, if you're running, I don't think you necessarily have to be super big to be interesting. I actually know a guy, he doesn't have too many machines and he's interesting for them. And why is that? Well, he has experience of telecom in small parts. He is in the right region. He happens to know how to cast with low silicon. And all of a sudden he is on the radar screen. Whilst we have 200 plus DC machine manufacturers that have failed to make an offer in time.
Yeah.
Think of it, then it starts to become interesting.
So it's basically back to something that we always say, adapt to the process, adapt to the customer, and deliver to them what they're needing, what they're craving for. And then you reach a point where you get the money for it, and that's what you want to have. Make a living wage.
I can take another example that I know by heart. If you're making an offer to a telecom company, you say, okay, the tooling is 100,000 euros. We would like to have 6,000 euros for doing this and 11,000 for doing that, meaning engineering and simulation stuff like that. As long as you tell before you're nominated, you're perfectly fine. And then it's not fine. And why is that? Well, because in telecom, they are super uninterested to have an extra discussion that will take time. It's not really only about the money that you're trying to grab some more money from a customer. It is more that they don't have the time, because when the project has reached that final stage, okay, let's go industrialization, let's make this baby fly. They don't have time to discuss 5,000 euros in a simulation with you guys. They want to just, are you on time? Will you deliver week 17? That's the only thing they have.
Way more outcome focused instead of these endless discussions because of some whatever simulation result.
Yeah, let me put this way. They don't pay for the endless discussion. They pay for innovation, result, and on time. In short, that's what they're paying for.
Yeah, I think that was an interesting lesson. Be quick, be flexible, and adapt to your customers' needs, and then you will have success in the telecom industry.
No, my final word will probably make the picture complete by saying, if you're interested, be there, and don't see it negative if you are not a super big company or experience in automotive and all that. It might be willingness and do the homework, and then you have a fair chance, I would say.
That's perfect. Then go grab the chance, and we are here in the next episode.
Yeah, exactly. Thank you for today. Bye.